Okay. Equation straight lines. Fundamental triangle gives you the most basic derivation of the equation of a straight line. I want you to understand how to do this. Okay? Then you got this standard form and this slope-intercept form. This is standard form, slope-intercept form. Everybody knows the slope-intercept form. Maybe you know the standard form. You almost certainly don't know this. Okay? Okay, well, first thing we do is we start with the fundamental triangle for the 2 points. Whatever the coordinates of this point are and whatever the coordinates of this point are, we do a fundamental triangle. So here we go. Yeah, tried to make it straight. That perspective. Okay, and I'm going to draw the triangle here. And this is x2 minus x1 going this way. And this is y2 minus y1. So the slope is y2 minus y1 over x2 minus x1. Okay. Everybody should completely understand that because y'all are pretty good with these. Okay? If you don't, get better. But I think, on the whole, we're doing pretty well with fundamental triangles. Okay? Well, I screwed up the way I drew it, but we're going to go on. Okay. Now, a straight line through x1, y1, and x2, y2, well, you know, it looks like this. Maybe I got it relatively straight, better than I expected. Okay? Okay. Well, we want to know what the condition is for point xy to be on the line. Okay? So, okay, there's some point on the line, right? And that point's going to have x and y coordinates. That point is going to be x, y. Okay? Okay, now I construct the fundamental triangle from the point x1, y1, and I'm going to have to go right through my label, but I'm going to do it anyway. Do it kind of lightly. Okay? So there's a new fundamental triangle. That side's pretty bowed, but you get the idea, you know what I'm doing. Okay? So I want you to label this side. You probably have to label it like here. Label this side and label the slope. Should just take you a minute. If you wanted to, you could even draw another triangle down low. Okay? It's hard to see because of the labeling up there. So, kind of quickly. What are the legs of the triangle? What's the slope? X2, Y2. Yeah, boy, I can't read it either. Need to run it over. Okay, well, I think most of you got it. If you didn't get it, you were close. This would be x minus x1. This would be y minus y1. And this would be y minus y1 over x minus x1. Okay, assuming you go in this direction. If you go in the other direction, then it'd be x1 minus x, y1 minus y. But better to have y minus y1 because your algebra in the next step is going to be a little easier. Not a big deal. Okay, a little easier. So up here I can label it. And there it is. Okay, well, if xy is on the line, then what can you say about the slopes of this triangle and this triangle? It's a straight line. Slope is the same between any 2 points. Okay? So big deal. Okay, well, this is a slope between 2 points, and this is a slope between 2 points. If xy is on the line, and this, we'll say some point on the line, we call xy, then think before you write. And we've got this, right? Okay. Now for homework, I'm going to ask you to solve this for y. What do you have to do to solve this for y? Well, you multiply both sides by x minus x1, right? And that'll give you y minus y1, then you add y1 to both sides. And we'll do a little more with the algebra in that next time. Okay. Well, that's this. We'll go on with it. We can easily prove that these two forms are equivalent to each other and to this. Okay? Okay, so I'll use a different color here. So I want to find myself here. I want to find the equation of the line through the points 2, 7 and 9, negative 4. Okay? Well, we can do a fundamental triangle. Let that be 2, 7, let this point be 9, negative 4. We can do the rise and the run, going in this direction. The rise is from 7 to negative 4, that's negative 11. The run goes from 2 to 9, which is 7. Slope is negative 11 over 7. Okay? So we know that m is the slope so that y is negative 11/7 x plus b. Okay? We can take the coordinates of either point we get this, so we can solve it for b. B is 71. Okay? Oh, nope. Thought that was a little high. Okay, just simple equation to solve for b. Now I chose to multiply both sides by 7, and then forgot to multiply b by 7, so for a minute there I was a little upset with it. Okay? Didn't think it was that high. But we get this. So, here's our equation. Okay? Now we go to this form. We're going to plug in the coordinates of our points, just like we do with the quadratic model. Okay? Here we've only got 2 points instead of 3, so it's going to be much simpler. Plug in the coordinates of our points, we get x is 2, y is 7, so we get 2x plus 7y shouldn't have had a c in there. Standard form, you have a 1 over here. Writing an A and a B, I just naturally wrote a C without thinking. Okay, so it's 1. Okay, so we have this, and then we have 9 and negative 4 for x and y. That's 9x minus 4y equals 1. Okay? This is our first equation. This is our second. We do 4 times the first, 7 times the second. We get 8x plus 28y equals 4. We get 63x minus 28y equals 7. We add and we get 71x, 71a, right, x and y instead of a and b. Okay, I think this will work. We get 71a, that's a, that's b, that's a, that's b. 71a equals 11. A equals 11 over 71. Plug that into one of these equations, and you get 2 times 11 over 71 plus 7b equals 1, etc. Okay? Multiply both sides by 71. That gets a little messy. Then you get kind of fractions, some big numbers for b. I mean, you're going to get 22 plus 700 and 491 b equals 71. 491 b equals 71 minus 22, which is 49. B equals 49 over 491. $497, not 491. Has to reduce, okay? Which equals 7 over 71. So if I did all that right, this is the value of A, this is the value of B. We have this, and if you solve this equation for y, you get this equation, so that's right. Okay? Now, you might have gotten lost in the details, especially since I wrote some of them pretty small, but it's just a matter of you take these 2 points, you plug them in, you multiply each equation by the right thing so they match up. So you eliminate B, you solve for A, you plug that into one of the equations, and you solve it for B. Just the same procedure we've used with the simultaneous equations for this flow model. Okay? So it all works. We've got about 4 minutes, so we can do this last one. Okay, on this model, what you would get would be y minus y1, so I'm going to plug these points in. Here's my x1, y1, here's my x2, y2, right? So we get y minus y1, which is y minus 7, over x minus 2, okay? And that equals y2 minus y1, which is negative 4 minus 7, divided by y2 minus y1, 9 minus 2. Okay? So you get right there's your negative 11 over 7. Now why should that be? Well, because y2 minus y1 over x2 minus x1 is the slope, right? And that agrees with the slope that we found up here, the negative 11 over 7, right? From this triangle. This triangle is actually the same as this triangle would be for this problem. And then we solve this, and if we simplify this, use the distributive law, we're going to get negative 11/7 x, right? Same as what we got here. And then we got 22/7, and we add that to 7, and we get 71/7. Okay? So I'm not going to do that last step because I'm out of room. But you want to practice until your fractions are up to doing this. Okay? And you want to understand this scheme. So I'm going to give you problems where you actually draw these triangles. I'll give you good directions because it's new. Okay? And see what you get down here. See that it agrees with this. And then you plug the coordinates of the points into this thing just for practice with simultaneous equations. And you take the first fundamental triangle you get over here and use that for your slope. And then this is kind of a hybrid thing. Here, you're not doing any simultaneous equations. Okay? Here, you got to do two simultaneous equations. Here, you use the slope, and then you plug the coordinates of just one point in to get the one unknown number. Okay? And I'll also ask you to do, for your quadratic model, I'm going to ask you to do a couple of things with that. Now, a lot of that will be due next week, but there's some that really needs to be done next time. Okay? You need to do at least one problem like this. There'll be a few more. Okay? They can kind of wait till next week. There'll be some logarithmic equations. Okay? And again, once you get the hang of those, they're pretty easy. Okay? There are always nasty things that can be done with those equations, and I won't do them today. Okay? We'll save the nasty stuff for later once you got the straightforward stuff down. And so that's what you can look forward to. Some of that stuff really needs to be done for Thursday, and I hope you've been working on the homework, because if not, it's really mounting up. Okay? And if you haven't done it, it's going to be harder to understand what we do next.